And so let's say we take the number 0.333 continuing. Now everybody knows what that should be, right? What's the rational form of 0.3 repeating? 1/3. Okay, so let's just see if the steps that we use here can verify that for us. All right, step 1 in transforming a repeated decimal into rational form is set the given number equal to x. Okay, once you set this equal to x, what you're going to do is you're going to identify how many digits repeat. Once again, that's going to equal n as a reference here. So in this number, how many digits are there repeating? There's just one repeating digit. Okay. What you're then going to do in your third step is you're going to multiply both sides of the equation in step 1 by 10 to the power of however many digits repeat. Okay, so we had one digit repeating, so 10 to the first is 10. So we're going to multiply the left side by 10, giving us 10x. And we're going to multiply the right side by 10. Multiplying by 10, or any powers of 10, is just going to move your decimals. So we're multiplying, move the decimal over one spot. Okay, so we get 3.3333, continuing. And once you set these up, you have these two equations. They're vertically stacked on top of each other. You're then going to subtract vertically. And you're going to solve for your x. So if we subtract vertically, we get 10x minus 1x is 9x. And what's always going to happen in this in this particular step right here is the repeating portion will be canceled completely. Okay, so here, when you subtract 0.333 repeating from 0.333 repeating, they just cancel out, leaving 3 minus a 0. And then your final step is to just reduce and solve for x. And so you're looking to solve for x here. To reduce it, 3 goes into 9, or 3 goes into 3 once, 3 goes into 9 3 times. So it reduces your fraction into that rational form of 1/3. Okay. This is this is the process that's used. Those of you who maybe were exposed to this, you might have proven that 0.99 repeating is equal to 1. Have you guys heard about that or done that? So if we set our number 0.999, I want you to follow this process to find the rational form of 0.9 repeating. So step 1, set x equal to the given number. Figure out how many digits repeat. 1. We're going to take 10 to that power and multiply both sides of the equation by that. So 10 to the first is 10. Multiply the left side by 10, we get 10x. Multiply the right side by 10, we get 9.99 repeating. Once again, by doing this step, we should cancel out all of the repeating decimals, which we do. And we get 10x minus 1x, which is 9x, equals 9 minus 0, which is 9. Divide by 9, and you get x is equal to 1. Okay. Questions on using this for a single digit repeating? Okay. All right, let's take it a little bit further. Okay, and I want you to see, can you find the rational form of this repeating decimal? 5.72, and again, it's the 7 2s that will continue. Step 1, set the number equal to x. Step 2, figure out how many digits repeat here. We have 2 repeating digits, so we're going to take 10 to the power of 2 and multiply both sides by that. So 10 squared is 100. 100 times x is 100x. And when we take 100 times 5.7272, we move the decimal 2 places over. So we get 572.7272, and so on. Okay, those repeating parts need to line up. Okay? They need to line up because when we stack them vertically and subtract, those should cancel. And so here we get 99x is equal to 572 minus 5 leaves you with 567. Divide by 99. And again, confirm. We have 567 divided by 99. In simplest form is 63 over 11. So here is the rational form for 5.727272. And we can confirm this by just taking that number, putting it into a decimal form, seeing what that decimal equivalent is, and you confirm that it is 5.72 repeating. Okay, easy. Now you just need to follow that process. Don't get in too big of a hurry. The mistakes that are made on this are usually made because students are trying to do everything in their calculator without just writing it out to show your steps. So if you miss it or get lost, it may be difficult to find your way back on. Colby.
On the last one where the value was 0.99 but it came out as 1, I'm so confused on that, like how, because it's supposed to represent the same value but it doesn't.
How 0.99 repeating is a value of 1?
It just it ended up coming out as 1, but isn't it, if it was 1?
It's a rational number. It's 9 over 9. So like if you look at that, so take, on your calculators, if you take 1 divided by 9 in decimal form, it's 0.111, right? So let's think about that pattern. So 1/9 is 1.11 repeating. 2/9 is going to be what? 0.2 repeating. 3/9, 0.3 repeating. So what's 9/9 going to be? 0.9 repeating. And so it's just another way to kind of verify that. Again, the reason why you choose 10 to the power of however many digits repeat is you need these digits to line back up. If we had done 10 to the first or 10 to the second here, so if we had done 10 to the first, we'd get 10x is equal to 136.146,146. And so now this 146 winds up being our repeating decimal. And so will these two cancel completely out? No, you'll still have a repeating decimal. So you need your repeating decimals to cancel each other out. So we need to figure out 1, 2, 3 digits repeat. So we're going to take 10 to the power of 3, multiply both sides by this. So we get 1000x is equal to, and here if we move the decimal 3 places, we get 13,614, 614, 614, and so on. Setting it up this way will allow the repeating portions to cancel out completely. And so we wind up with 999x is equal to 13,601. Divide both sides by 999. And we can verify 13,601 divided by 999. Does this simplify any? No. So this is our rational form. We can check it to see by putting a decimal in here, hitting the green diamond button, finding what the decimal equivalent is, 13.614614. That was our original number, so it verifies as being correct.